All right, so what we're going to do is solve a system of equations by using matrix inverses. So I picked one that's not going to be necessarily easy to solve using Gauss-Jordan or any other method by hand, really. So the idea is, though, we first have to write the system in matrix form, and remember that this left-hand side can be written as the coefficients in one matrix are 2 by 2. Our unknown matrix, which we call X, and then our right-hand side matrix. So remember that this follows the format AX equals B. So remember that if we have AX equals B, that translates to X equals A inverse times B. So what we need to do is find the inverse of matrix A and then multiply it by B, and boom, we have our solution. So first thing to do is find the inverse of 10, 7, 7, 5. Now, you can use a calculator to do that or any kind of technology, or since this is a 2 by 2, we can use the shortcut formula. So remember that the shortcut formula is 1 over, so it's AD minus BC, or main diagonal minus other diagonal, times the matrix where we interchange the main diagonal elements and we negate the other diagonal elements. So simplifying this, so remember this here is A inverse. So if we simplify this, this guy is just 1. Okay, so that means that A inverse is 5, negative 7, negative 7, 10. How nice is that? So that means that X is equal to the inverse, 5, negative 7, negative 7, 10, times the B matrix, which is 1, 1. So this is A inverse, this is B. And we know that when we multiply these together, we get a 2 by 2 and a 2 by 1. So that means our result is going to be a 2 by 1, which is what we want. So we have, so this first entry is 5 times 1 minus 7 times 1, which is negative 2. And negative 7 times 1 plus 10 times 1, and that gives us 3. So this tells me that X is equal to negative 2, Y is equal to 3, and that can easily be verified by plugging in that solution to each equation in the system. So there is using the matrix method to solve a system of equations.